Hello guys, so the given question says the hydride that is not electron deficient is. So here we have determined the among these hydrides which is not electron deficient. So the hydride in which the central atom's octet is not complete is electron deficient, and in which the central atom's octet is complete is not electron deficient. So let's check one by one. So in the first option here given the aluminium hydride. So aluminium has 3 valence electron like this, and it is shared with 3 hydrogens. Here hydrogen, here 1 electron of hydrogen, and here hydrogen, here 1 electron of hydrogen. So as you can see, there are only 6 electrons around the central atom, that is aluminium, that is 6 electron, which is not 8. So the octet not complete in this case. So it is electron deficient hydride. Now moving on the second option. So in second option given that gallium hydride, so gallium is placed next to the aluminium, so it is also have 3 valence electron like this and shared with 3 hydrogen like this. So here again, as you can see, 2 plus 2 plus 2, 6 electron. So it is also a electron deficient species. Now moving to the third option. So here in third option given that silicon hydride. So in silicon hydride, silicon is central atom, and we know that silicon has 4 valence electron because it is placed below to the carbon, and each electron shared with the hydrogen atom. So as you can see here, the total 8 electron around the silicon, which means octet complete. So it is not electron deficient species. Now if we look at the fourth option, so in fourth option here given that B2H6. So if we draw the structure of B2H6, it look like the 2 boron. Now boron has 3 valence electron, so 2 shared with hydrogen like this, and it contains 2 bridge hydrogen, and the each bridge bond only contain 2 electron and 3 centers. Here electron, here hydrogen, electron. If you count the electron around each boron, so here 1, 2, 3, 4, 5 and 6. So only 6 electron around this boron, and similarly 2 plus 2, 1, 1. That is 6 electron around this boron. So again the central atom's octet is not complete, so it is also electron deficient hydride. So only silicon hydride, and that is SiH4, is not electron deficient, and all other are electron deficient. So option number 3 is correct and all other options are incorrect. I hope you understand. Thank you.
Hello, the question says that the correct statement among A to D regarding H2 as a fuel are. So we have 4 statements A, B, C and D. So we need to find which statement is correct. So let's analyze all statements one by one. So first statement is it produces less pollutant than petrol. So our A statement is true because H2 is zero emission fuel. And second statement is a cylinder if compressed dihydrogen weight 30 times more than a petrol tank producing the same amount of energy. So our second statement is also true because H2 has high calorific value. So as calorific value increases, energy produced will be increases. So our third statement is dihydrogen is stored in tanks of metal alloy like NaNi5. So our C statement is also true because hydrogen is widely stored in tanks of metal alloys like NaNi5. Stored in tanks. Our D statement is on combustion, value of energy released per gram of liquid hydrogen and LPG are 50 and 142 kilojoule per respectively. Our D statement is false because LPG produces less energy than liquid hydrogen. Liquid hydrogen. So our statement A, B, C are correct one. So our option number second is correct. Thank you.
Our question is sodium hydride is an example of sodium hydride. This is an alkali metal hydride. This is alkali metal hydride. Example of alkali metal are lithium, sodium, potassium, etc. Hydrides are hydrogen anion. Hydrogen anion, which is H negative. Anions are chemical species which possesses negative charge. Sodium hydride is obtained by the reaction metallic sodium with hydrogen, which is sodium react with hydrogen. It will form sodium hydride. Balance the equation here to here too. Sodium hydride has a structure like sodium chloride. So each sodium ion is surrounded by 6 hydride ion and having octahedral geometry. Okay, let us see option. Let us see option one by one. First is electron rich hydride. Electron rich hydride. As the name suggests, electron rich hydrides are hydride which have excess electrons, which are present in the form of lone pairs. So element of group 15, 16, 17 form such compound. Example, ammonia, water, etc. Second is, so this is not the correct option. Let us say third, which is second option, metallic hydride. Metallic hydride, or also known as interstitial hydride. D and F block elements on heating with dihydrogen under pressure form hydrides. Okay, so hydrogen atom are small in size. Hydrogen atom, due to which they occupy some space in metallic lattice, which causes distortion without any change. That is why such hydrides are called interstitial hydrides. So this option is also not correct because sodium is not belong to D and F block elements. It is belong to S block element. Let us say saline hydride. Saline hydride are also called ionic hydride. Metal having electronegativity lower than hydrogen form such hydride. All elements of group 1 and group 2 when heated form ionic hydride. Okay, and we know that sodium belongs to group 1 element. and its electron activity is lower than hydrogen. So from here we can say that sodium hydride is saline hydride. So from here we can say that option 3 is the correct answer of this question. Saline hydride, sodium hydride is an example of saline hydride. Let us see option 4 also, which is molecular hydride. Molecular hydride, or also called covalent hydride. These are usually volatile compound. Group 13 elements form such hydride. So group 13 elements are called molecular hydride. So as we know that sodium is belong to group 1. So this option is not correct. Option 3 is the correct answer of this question.